Hi. So far we have seen that interference, diffraction, polarization, they can be all explained using the wave behavior. But when we talk about photoelectric effect or black body spectrum, we think of light as quantized energy bundles called photons or called quantas, and then the wave behave as particles. Neil Bohr has suggested that the nucleus is in the center and electrons revolve around the nucleus in particular energy orbits. They cannot have any energy value, they need to have a discrete energy value according to the orbit in which they are revolving. Louis de Broglie, a French physicist, he thought that why electron cannot have any energy value, why it has to be discrete. All right, and in 1924 he proposed wave particle duality. He suggested then when waves can behave as particles, then why not particles can sometimes behave as waves. All right, so he proposed that wave particle can be, their characteristics can be interchanged to explain certain phenomenon. In 1927 his hypothesis was experimentally proved, and in 1929 he received the Nobel Prize for it. All right, so Louis de Broglie suggested that a moving body behaves in certain way as though it has a wave nature. He has given the formula to find wavelength for any object. It can be me, it can be a golf ball, it can be an electron, because at certain point all the particles or all the matter, they behave as waves, and sometimes waves, they behave as particles. So the formula for wavelength is lambda equals to h divided by p, where h is the Planck's constant, p is the momentum, and lambda here is called after the name of the scientist, de Broglie wavelength. Let's solve a numerical to calculate de Broglie wavelength. The question is, find the de Broglie wavelength of a 46-gram golf ball with a velocity of 30 meters per second, and part B, an electron with a velocity of 10 to the power 7 meter per second. This is 7. Okay, let's solve for part A first. Mass is given 46 grams, that is 46 times 10 to the power minus 3 kilograms. Velocity is given 30 meter per second. The formula for de Broglie wavelength is lambda equals to h over p. Momentum can be written as mass times velocity. So it's just, we have to just put in the numerical values. 6.6 times 10 to the power minus 34 divided by 46 times 10 to the power minus 3 times 30. Plug this in your calculator and you will find the answer is 4.8 times 10 to the power minus 34 meter. Let's have a look at this value here. 10 to the power minus 34 meter. When a golf ball is moving, and if it is behaving as a wave as per de Broglie hypothesis, then its wavelength is of this magnitude, which we cannot observe in day-to-day life. Alright, so this is the wavelength for a golf ball. Now let's see what will be the wavelength for an electron. I'm just rubbing this off. If you want, you can pause the video and solve it yourself. Mass of an electron is 9.1 times 10 to the power minus 31 kg. Velocity is given 10 to the power 7 meter per second. Lambda equals to h over mv. 6.6 times 10 to the power minus 34 divided by 9.1 times 10 to the power minus 31 times 10 to the power 7. Plug it in your calculators and the answer you will find is 7.3 times 10 to the power minus 11 meter. Now this is something, when you convert it in nanometers, that it's measurable. Alright, so wavelength of electron is comparable to its own size. Okay, and therefore the wave nature of electron can be observed. Alright, and which is key to understanding the structure and behavior of atoms and subatomic particles. Alright. In 1927, in two different parts of the world, in the same year, scientists proved de Broglie hypothesis. Clinton Davison and Lester German in USA, and G.P. Thomson. He is the son of J.J. Thomson, who discovered electrons. He did the experiment in England, and they both proved that yes, de Broglie hypothesis is correct and particles behave as waves. Alright, so wave-particle duality was established. Now, let's talk first about Clinton Davison and Lester German experiment. They had a setup like something like this, where the incident beam of electrons, it was accelerated, the energy could be changed. It was incident on a nickel block and they were all diffracted or scattered. They had an electron detector which could also be varied, the position could be varied, and they noticed that the scattered beam of electrons, it interfered and it created a diffraction pattern of high intensity, low intensity, high intensity, low intensity, just like just like wave pattern. So therefore they proved that yes, de Broglie hypothesis is correct, and when electrons are diffracted from a nickel block, then they produce interference pattern. What G.P. Thomson did was that in place of this nickel block, he placed a very thin gold foil, and rather than this electron detector, he had a detector around the gold foil, so that wherever the electron will scatter, he can capture it everywhere. And he also found the same thing, that the pattern was of dark fringe, bright fringe, dark fringe, bright fringe, just as the wave. G.P. Thomson did one more thing. He did the same experiment first with electrons, and he did the same experiment then with X-rays. The results he got was pretty similar, and thus he could conclude that yes, when the wavelength of electron, when electrons are behaving as waves, it is pretty close to the wavelength of X-rays, because when he hit both at the same gold foil, he got the same interference pattern. Okay, so this is the proof that yes, de Broglie hypothesis was correct. Waves behave as particles and particles also behave as waves. Now coming back to Niels Bohr and how de Broglie was thinking that why electrons have to be in particular orbits or particular shells. So he thought of standing waves. What he thought, just a quick revision for standing waves. In this, when we make standing waves, they are trapped. Think of it as trapped in a box, and the corners make nodes, and there are antinodes in between. You get first harmonics, second harmonics, or third harmonics. This is all in year 11 physics waves, and they can only have wavelength according to a particular integer values. They cannot have any value of the wavelength. Alright, so what de Broglie suggested was that electrons, while revolving around the nucleus, okay, let's say if this is the nucleus, and when they revolve around the nucleus, they resonate and they form standing wave within themselves. Alright, they form standing waves, and therefore, for example, let's say this is two strings, fixed ends of a string, okay, and this is a standing wave. Now, to visualize it for a atom, just think of it as a circle. Okay, so electron is moving around the nucleus in the form of a circle, and I have drawn it in a way that where this meets the start, then it has to be like the start. The wave should be in continuation. All right, it cannot be any value. The wave cannot be like this. No, it will not exist. This is not what standing waves behave like. It has to be in continuation. So therefore, if you say that the circumference is 2 pi r, then it has to be equal to certain integer multiple of the wavelength. Okay, because de Broglie visualized electronic wave as standing waves. Alright, and therefore we are talking about a circle, so the total distance traveled will be 2 pi r, where r is the radius. That should be equal to a full integer multiple of lambda. It cannot be like this. If it is like this, then electron cannot exist in that particular radius. It will try to find a radius where it can have a standing wave within itself. Alright, so this is why electron can only be in a particular orbit. It cannot be in any orbit. Now, he also suggested that when an electron absorbs a photon, it jumps to higher orbit, right? So why does this happen? Because let's say that it absorbs a photon and then it adds one wave to it, and therefore when it adds a wave to it, its radius increases. Its radius increases and it adds more waves to it, standing waves to it, and therefore when it releases a photon, it has to decrease the wave. So therefore de Broglie could explain why Niels Bohr thought that electron can only be in particular orbits. Alright. So if I say this as circumference, C equals to n lambda, where lambda is h over mv. So if you have been given radius, then you can calculate the velocity, and if you know which orbit it is, you can do the mathematical calculations using this formula. So a quick recap. In 1924, de Broglie suggested the hypothesis of wave-particle duality. In 1927, it was proved experimentally in 2 different parts of world using the same diffraction method of electrons, and they found that yes, it is true. In 1929, de Broglie received the Nobel Prize for it. And using the wave-particle duality, he could explain Niels Bohr's model of atom, that why electrons can only exist in particular orbits. Alright, thank you.